I'm analyzing how the parameters of the RANSACRegressor algorithm affect its performance in identifying inliers, data points that fit the model well, and outliers, data points that don't fit. This is key to understanding the results of this quiz. We are using the RANSACRegressor, Random Sample Consensus Regressor, from Sklearn to find the best fitting line for data that has outliers. I set a minimum of 5 data points, min_samples, to fit a line, and I set a maximum acceptable distance from the line, residual_threshold, to 1.0. However, only 20% of my data points are classified as inliers. What went wrong? I'm going to systematically analyze each part of the problem to see why I'm getting this unexpected result. I'll examine each parameter setting and consider whether there's too many outliers. A high residual_threshold means I'm allowing points that are far from the line to be counted as inliers. This could explain why I only have 20% of points classified as inliers. They might be inliers according to a relaxed threshold, however not according to the true model. If my dataset is heavily contaminated with outliers, even a well-tuned RANSACRegressor would have difficulty finding enough inliers to create a reliable model. That could cause the issue I'm seeing. I'm setting min_samples to 5. That's not usually too low, and is unlikely to be the main cause. I need more points than this. It's unlikely that the algorithm failed to converge. RANSAC usually converges, even with many outliers. I got a result, even if it is a bad one, but it's a result nonetheless. I'll examine whether my choice for the minimum number of data points needed to fit a model, min_samples, is reasonable for this task. I see RANSACRegressor, that's Sklearn's algorithm for fitting models to data with outliers. The analysis here focuses on how the parameters min_samples and residual_threshold influence the algorithm's performance, specifically affecting the number of data points identified as inliers. We will analyze its behavior given a specific outcome. We are given a scenario. RANSACRegressor is used, with min_samples set to 5 and residual_threshold to 1.0. Only 20% of data points are classified as inliers after model fitting. The goal is to determine what might have caused such low inlier percentage. I believe a substantial number of outliers in the dataset is a very plausible explanation. Even a well-tuned RANSAC model struggles to find many inliers if the dataset is heavily polluted with outliers. They would increase the residuals, making it difficult to establish a robust model which fits most data points. I think that a min_samples value of 5 is generally reasonable for a RANSACRegressor. Thus, it's not the main reason for the low inlier percentage. Having such a low value might create problems for other algorithms, but not for this case. I don't think the algorithm failed to converge. RANSAC typically converges even with many outliers. The low inlier percentage suggests convergence to a model that wasn't a very good fit to the data due to parameter settings or the large number of outliers. I think a residual_threshold of 1.0 could indeed be too high. This means a point needs to be pretty far from the current model to be deemed an outlier. A higher threshold allows points that are actually far from the true underlying model to be considered inliers, making the model inaccurate and resulting in a small set of inliers. This makes a high residual_threshold a significant potential contributor to the problem. I'm analyzing the parameters of the RANSACRegressor algorithm. I'm focusing on how the choices we make affect the model's performance, especially its ability to handle noisy data. RANSAC, or Random Sample Consensus, is a robust method that's designed to fit models even when the data has many outliers. We're presented with a scenario where we're using the RANSACRegressor from the Sklearn library in Python. The task is to fit a linear model to data containing outliers. The parameters are set, and the results show that only 20% of data points are classified as inliers. My job is to investigate why. This is a likely culprit. A high residual_threshold means RANSAC considers points far from the model as inliers. It's like setting the bar too low, many points that are actually far from the line can be incorrectly included as part of the good data points. This would lead to a lower percentage of inliers than expected. Even a perfectly tuned RANSAC algorithm will struggle if the data is overwhelmed with outliers. Think of it like trying to find the true average height of a class when many students are significantly taller or shorter than average. The true average will be harder to find if the outliers greatly outweigh the typical students. The algorithm will still find some inliers, but the overall percentage will be small. While a very small min_samples value could be problematic, 5 is usually adequate. I don't believe it's the main reason for the low inlier count. The problem is more likely to be either a high threshold or many outliers. While it is possible this is less likely. RANSAC typically converges, even with outliers present. The algorithm will find a solution, but the quality of that solution may be poor depending on parameters or the data's quality. The data points are the individual measurements that are fed into the RANSACRegressor algorithm. These points are analyzed, and based on the set parameters, the algorithm decides whether each point is an inlier, a data point considered consistent with the model, or an outlier, a point that deviates significantly from the model. I'm analyzing the parameters of the RANSACRegressor, a robust linear model fitting algorithm used in machine learning. It's designed to handle outliers effectively. The key parameters we're investigating are min_samples minimum data points to fit a model, and residual_threshold maximum acceptable distance from a point to the model. The problem presents a situation where only 20% of the data points are classified as inliers after fitting a linear model using RANSACRegressor. I've set min_samples to 5, meaning a model is fitted using at least 5 data points, and residual_threshold to 1.0. Data points more than 1 unit away from the fitted model are considered outliers. This low inlier percentage is the puzzle we need to solve. I believe this is a possible explanation. A high residual_threshold allows points to be considered inliers even if they're far from the best fitting line. A more restrictive threshold might result in more points being accurately classified as inliers. Let's see if this is the case. I think it's highly probable that the dataset contains a significant number of outliers. Even with a well-tuned RANSACRegressor, a large number of outliers would make finding a reliable model difficult. The algorithm would have trouble identifying the true pattern amidst these outliers. I find this less likely, given that the value of 5 for min_samples is generally reasonable. While a very low value could be problematic, this is not the primary factor explaining such a low inlier percentage. This is the least likely scenario. Although it's possible, the RANSAC algorithm usually finds a solution, even with many outliers. The fact that we have some inliers suggests the algorithm converged, even if the final result isn't very satisfactory. Based on my analysis, the most likely explanations are a too high residual_threshold and the presence of many outliers in the dataset. Both factors could contribute to the low percentage of inliers detected by RANSACRegressor. I'm analyzing how the parameters of the RANSACRegressor algorithm, specifically min_samples and residual_threshold affect the model's performance. RANSAC stands for Random Sample Consensus, by the way. It's a robust method for fitting models to data with outliers. We're given that only 20% of the data points are considered inliers when using RANSACRegressor. That means 80% are flagged as outliers. The algorithm used min_samples minimum number of data points needed to fit a model, as 5 and residual_threshold maximum distance for points to be inliers, as 1.0. I want to figure out why so few points are considered inliers. I'm exploring several possible explanations for the low inlier percentage. It could be due to a high residual_threshold a high number of outliers in the data, a low min_samples or a failure of the algorithm to converge. A high residual_threshold would make it easier for points, even those far from the model, to be accepted as inliers. Think of it like having a really big net. You'll catch lots of fish, even the ones that don't really belong to the school. A large number of outliers in the data would make it difficult to fit the model properly. Even a well-tuned RANSACRegressor would struggle to find a good fit if the data is significantly contaminated with outliers. A low "min_samples" value might make the model too sensitive to noise or outliers. However, 5 is usually a reasonable value. It's less likely to be the main issue here. RANSAC typically converges. Since the algorithm produced a result, albeit a poor one, it probably didn't fail to converge. The problem is more likely caused by parameters or the data itself. Based on my analysis, I think a high "residual_threshold" and a large number of outliers are the most likely reasons for only 20% of the data points being classified as inliers. I see only 20% of the data points are considered inliers. That means the RANSAC algorithm deemed only 20% of the data points to be close enough to the fitted line. This is a relatively small percentage, suggesting a potential problem with either the "residual_threshold" or a large number of outliers. Let's investigate. That implies a whopping 80% of the data points are considered outliers. This is a significant portion of the dataset. It's highly suggestive that the dataset might be heavily contaminated by noise or inaccurate data points. I'm analyzing the parameters of the RANSACRegressor. RANSAC, or Random Sample Consensus, is an algorithm robust to outliers. It iteratively fits a model to random subsets of data points and selects the model that minimizes the distances between the data points and the model. The "min_samples" parameter determines the minimum sample size for the random subsets, while the "residual_threshold" sets the maximum permissible distance between a point and the model. We need to check if the values of these parameters are causing issues. This part of the question looks at the actual steps within the RANSAC algorithm. The algorithm is iterative, it samples data, fits a model, and refines its model iteratively. In this context, understanding the process helps in assessing whether a low inlier percentage results from a problem with the parameters, the data, or the convergence process itself. I'll look for clues within the process to check why so few data points are considered inliers. Let's see what happened here. I'm analyzing the parameters of the RANSACRegressor, a robust algorithm for fitting a linear model to data with outliers. We'll focus on how the "min_samples" and "residual_threshold" affect the algorithm's performance. Think of RANSAC as a detective carefully investigating a crime scene. It selectively picks subsets of data points to build its case, model, and discards unreliable evidence, outliers. You are using RANSACRegressor. RANSAC stands for Random Sample Consensus. In scikit, learn to fit a linear model to data with outliers. You set the minimum number of data points for each model fit, "min_samples" to 5 and the maximum acceptable error, "residual_threshold" to 1.0. After fitting, only 20% of your data points are considered inliers, points fitting well to the model. Why? A high "residual_threshold" means the algorithm is too lenient. It's accepting points that are far from the model as inliers. This is like a detective accepting very weak evidence, leading to a poorly constructed case. It's a likely cause of the low inlier percentage. If there's a significant number of outliers, then even a well-tuned RANSAC model might struggle to find a significant number of data points that fit the model well. This is like having a lot of false clues at the crime scene, making the detective's job much harder. A low "min_samples" value can sometimes be problematic, but in this case, 5 is a reasonable value. The low inlier percentage is more likely due to the "residual_threshold" or the number of outliers. RANSAC usually converges, even with lots of outliers. The algorithm found a solution, just a poor one with a small inlier set, likely because of the parameter settings or the outlier amount. I've concluded that both A and C are the most probable explanations for only 20% of the data points being classified as inliers. Either the "residual_threshold" is too high or the data has a large amount of outliers, or potentially both.